Hello students, welcome back to my channel. Here this is the second part of your chapter 1, that is chemical reaction and equation, where I am going to explain you the balancing of the chemical reaction by the method that is given in the textbook, as well as a very simple method of balancing the chemical reaction. Hope you are going to enjoy this second method and you'll find it very simple balancing any big reaction. So let us start with balancing the chemical reaction. Let us start with balancing chemical equation. Students, what is balancing chemical equation? Why it is required? Students, it is always seen that in a chemical reaction, always the chemical reactions or the substances follow or hold true the law of conservation of mass. What is law of conservation of mass, students? Law of conservation of mass is matter can neither be created nor destroyed in a chemical reaction. That is, the number of elements, mass of the number of elements or molecules involved in a chemical reaction always remains same as the mass of the reactant and as the mass of the product. So the mass of the product and the reactant is always same. So when we are writing the chemical reaction, we don't know how many molecules of a particular reactant is taking part in the chemical reaction, how many number of molecules on the product side of a particular product is formed. So this is what we can come to know by balancing the chemical reaction. So first we will be talking about the method that is given in your textbook, and then I'll be teaching you one very simple method which is known as algebraic method of balancing the chemical equation. So stepwise balancing, which is known as heat and trial method. According to this particular method, what we are supposed to do is, first we have to write down the chemical equation using the molecular formula. So this is the reaction what we are going to say. Take example where Fe plus H2O is giving you Fe3O4 plus hydrogen. Now over here you can see that Fe is one atom while over here it is 3. Hydrogen is 2, but oxygen is 1 over here, on this side is 4. So by mass if we try to see, they are different. But it is not practically so, because this is not a balanced chemical equation. So if we just write down the equation, we won't be able to know how many ion is reacting with how many water molecule to how many say product of Fe3O4, how many molecules of Fe3O4, how many molecules of hydrogen. So for that we will have to balance it first. So the second is count the number of atoms of each element on both the side of the chemical equation and write down in this particular format. So when we write down this in this particular format, say Fe, first you have to list out the elements Fe, then hydrogen and then oxygen. There is no need to go on the product side, because whatever is on the reactant side, the same elements are going to be on the product side. So the number of atoms on the reactant side is 1, Fe is 1, while on the product side it is 3 Fe. So I have written 3 over here. Hydrogen, there are 2 on the reactant side and 2 on the product side, meaning hydrogen is equal on both the side, while oxygen is 1 on the reactant side and 4 on the product side. Okay, meaning over here Fe and oxygen, they are not balanced on both the side, that is reactant side and the product side, according to law of conservation of mass. So we should know how many number of molecules of Fe is reacting to form how many number of molecules of Fe3O4. So now the third step. Step 3 says that you are supposed to equalize the number of atoms of element which has maximum number by putting in front of it. Meaning the first you are supposed to equalize or equate, make number equal of the atom which is having the maximum number. So here we are having maximum, that is over here oxygen. Oxygen we had 4 on the other side. Here let me just show you the table again. About oxygen, we have 4 maximum. 3, 2 and 4. So the maximum number is of 4. So we are putting 4, or we are balancing oxygen first. Because it is 4 over here, we are balancing oxygen first by writing 4 in front of the reactant side. Because it is maximum over here, we have to write 4 over here. 4 would have been over here, and over here it would be less, then we would have written 4 over here. So the one which is having maximum number, so if you see over here, O is having maximum, so we are writing 4 over here. The fourth step, try to equalize all the atoms of elements on the reactant and product side by adding coefficient in front of it. So we had written 4 on the other side. So when we are writing 4 over here, it is going to affect hydrogen, because 4 2s are 8. Hydrogen becomes 8. No doubt we have balanced oxygen, but the hydrogen is getting imbalanced. So here again we will have to write 4. Then so now hydrogen is balanced, oxygen is balanced, but iron, that is 3 on this side. So by writing 3 over here, we will be making 3 Fe. So now it is a balanced one, that is 3 Fe, meaning 3 atoms of iron is reacting with 4 moles of water to give 1 mole of Fe3O4 and 4 moles of hydrogen. So now if you try to see Fe, hydrogen and oxygen on the reactant side, the number of this 3 is going to be equal to Fe, O and hydrogen on the product side respectively. Okay, and the next step will be, you are supposed to write down the physical state of the reactant, that is this I had not written, as iron taken is in solid state, water is in the gaseous state, Fe3O formed is in the solid state, while again water over here is formed in the gaseous state. So we are supposed to write down the state in which they are present. Clear, students? And later on, if there is any condition necessary like temperature, pressure or any catalyst is required, then it has to be written on this particular arrow as I have explained you before. Okay, clear, students?